Let's talk about something a little weird. We've got AIs that can write poetry, ace law school exams, and generate mind-blowing code. And yet, have you ever noticed how they can be just incredibly forgetful? It's this huge puzzle. Why does this super powerful tech struggle with something so fundamentally human as memory?
I'm willing to bet we've all been here. You ask a chatbot a question, you get a perfect answer, and then you ask a follow-up, and suddenly it's a complete blank slate. It has absolutely no idea what you were just talking about. It's a super common and, let's be honest, a pretty frustrating experience.
So that really is the central question, isn't it? Why this massive disconnect? How can something so smart have the memory of a goldfish? Well, it turns out the answer is really interesting, and it gets to the core of how these things actually work.
And here's the key. This forgetfulness, this amnesia, is actually the default setting. Most AI agents are built to be stateless. That's just a fancy way of saying they react to one single input at a time. So to get beyond these simple one-off interactions and move towards anything resembling real intelligence, AI has to learn how to remember.
Okay, so let's start with layer 1. You could think of this just like our own short-term or working memory. This is all about the nuts and bolts of how an AI manages to keep a conversation on track from one sentence to the next.
The most basic way they do this is with something called buffer memory, and it's pretty much exactly what it sounds like. It's a temporary holding spot, a buffer, that keeps a running list of the last few messages. This is the magic that lets a chatbot answer a follow-up question without you having to restate the entire context every single time.
But here's the catch. This buffer memory is great for making a short chat feel natural. The problem is, it has a hard limit. As soon as the conversation gets too long, or you close the window and come back tomorrow, that memory is just gone. Poof, vanished. So to get around that pretty major limitation, developers came up with a pretty clever workaround, summary memory. Instead of trying to hold on to every single word, the AI will just pause every so often and create a summary of what you've talked about so far. It's basically creating its own set of cliff notes for your conversation.
Now, this is way more efficient, and it really helps keep the main thread of a conversation going for a lot longer. The big risk, though? You can lose all the subtle stuff. If the AI's summary misses one tiny, crucial detail, it could completely change the meaning of the entire interaction later on.
Okay, so let's level up. If working memory is about holding a conversation in the moment, this next layer is all about recalling specific facts and experiences from the past. You can think of it like giving the AI its own personal, searchable library. And this is where it starts to get really cool. This system is called vector memory. It doesn't just store information based on keywords. It stores it based on its conceptual meaning. This lets the AI search its library for related ideas, not just exact word matches. It's a game changer.
This is unbelievably powerful for anything that needs deep knowledge, like a research assistant that can pull the one perfect paragraph out of 10,000 documents. The downside, of course, is that building and maintaining this kind of conceptual library is a pretty complex and resource-heavy job. Check this out. This is a perfect example of how powerful that conceptual search is. Researchers found a model could predict that the word development would come after a sentence about Joseph Warbrick's impact on rugby. Now why? Because its vector memory dug through its training data and found a super similar context about that same person. It's not just guessing, it's recognizing deep conceptual patterns at a massive scale.
So far, we've covered remembering things, but what about learning from those memories? This is where we get to the really advanced stuff, giving an AI something like metacognition, the ability to actually think about its own thinking. It's called reflection-based memory, and it lets an agent look back on a decision it made, analyze what happened, and literally ask itself, hey, did that work? And if not, what should I try differently next time? This right here is the absolute bedrock of real, continuous learning.
And that's really the heart of it. Reflection is what takes an AI from being a simple tool that just follows instructions to being a genuine agent that can form its own strategy, adapt, and actually get better over time all by itself.
One of the most powerful ways this is being put into practice is with something called the REACT framework. It's all about creating this powerful feedback loop between the AI's internal thoughts, its reasoning, and its external actions, like searching an API or using a tool.
So the way it works is this simple, but really effective loop. First, the AI thinks, okay, what do I need to do here? Then it takes an action. It executes that step. Then it observes the results. And based on that new information, it updates its original thought and plans the next action. It's just this constant, iterative cycle of thought, action, observation, repeat. Okay, so we've got all these different pieces, right? We've got working memory, a deep knowledge library, and this ability to reflect and learn. So how does it all come together? Well, you combine them into a hybrid architecture, kind of like building a brain with different regions specialized for different jobs.
A truly sophisticated AI doesn't just pick one type of memory. It uses the right tool for the job. It's got buffer memory for that real-time chat, summary memory to keep track of the big picture, vector memory to look up hard facts, and something called episodic memory, which is a log of its own actions so it can reflect and learn later.
And I want to be really clear. This is not just some theoretical concept from a research paper. This is happening right now. There are real-world platforms dedicated to building these stateful agents, AIs that are designed from the ground up to have memory, to learn, and to improve themselves.
In fact, look at this. This is an actual piece of code from a platform called Letta. You can see the developer is literally creating separate memory blocks. There's one labeled human to remember things about the user, and another one labeled persona, so the AI remembers who it is supposed to be. This is memory being programmed right here.
So what does all this mean? Where is it all heading? Well, it's leading us to a future that is fundamentally stateful. This whole quest for AI memory, it's really about transforming AI from a simple one-and-done tool into a persistent, collaborative partner.
And what does that actually look like in practice? Well, it might look like an AI that can explain exactly why this meme is funny. An AI like that isn't just spitting back data. It gets context, it gets nuance, it understands the absurdity of putting chicken nuggets next to a majestic image of Earth. That level of understanding is only possible when you combine a powerful model with a sophisticated memory.
Which leaves us with one last really big question. If an AI can remember its past, if it can truly learn from its own mistakes, and if it can understand subtle human context, what does it become? It's not just a tool anymore. The real question is, what comes next?